October 1, 2013, Unit 2, Cape IT, Module 1, Objective 1, differentiate amongst the terms used in information management. In discussing information management, it is based on database principle. And that is, we're going to discuss the words fields, records, tables, files, databases, and database management system. As you learned in CXC, a field is a unit of information within a database table. So each database table has different columns, and therefore each column is a field within that table. It's a unit of information within a database table. A field is also called an attribute. It's a thing about the entity that we're speaking about. We're talking about equipment. It's an entity. It has a name, a serial number, a cost, a manufacture date, etc. We also have what is called a record. A record in the context of a relational database, a record in the context of a relational database is a row of information within a database table. A record is a row of information within a database table. A record is also called a tuple, T-U-P-L-E, tuple. In the context of a relational database, a record, also called a record or tuple, represents a single implicitly structured data item in the table. In simple terms, a database table can be thought of consisting of many rows and columns, and the columns are called fields, while the rows are called records. Each row represents a set of related data. Every row in the table will have the same structure. So all the field names being filled out going across in the row will create a record for you. Mushesh? Okay. There is a table. A table is a collection of records that are related to each other. The table information are normally arranged in a logical manner. A table is a collection of several records that are related. So if you look at the example on your PowerPoint, you would see that there is a table called project. In that table, how many fields are in the project table? 2. Project ID and project name. How many records are in that project table? 3. One record has ID 1214, one has ID 1709, and one has ID 1737. So there are 3 records within that table. As I said in the notes, the records in a table are normally arranged in a logical sequence. If it's a personal table, in database you know the primary key comes first. So you have the person ID, surname, last name, address, town, date of birth, the fee for registration, etc. And this contains several fields that are related to the person. So all the records in the database are related. In that table, they are related. If it's a personal table, it will only store personal information. The next term you have is the term of a file, a database file. Now, if somebody could just check a textbook, please. A database and a database file are similar terms. According to your Discovering Computers 2004, Shelley Cashman et al., she stated A database is a collection of data organized in a manner that allows a user to access, retrieve, and use the data. Shelley Cashman in her book said in 2004, a database is a collection of data organized in a manner that allows a user to access, retrieve, and use data. So you can access the data. You can get to it. So your phone book in your phone is a database. You can access the record that you store. You can retrieve a particular contact by start typing in their name, and the contacts come up on the screen. And you also are able to use that data. So you could copy a cell phone number from a contact and paste it into a text message or email. Yes? Or you could send a contact in your phone to somebody on your WhatsApp or your BBM Messenger list. A database file. Could somebody give me a definition of that, please? Google it. I'm not seeing it here. Now, sorry, I didn't hear that.
There's a file from which a primary master name server loads to locate.
Find something else. Cross-reference to something else. If you find a definition somewhere, always check a next source to make sure you get the same thing. Database file, anybody? A database file or data file. Data file is in Microsoft Word, mail merge. So they said a while ago. Alright, you can look up the word database file in your own spare time. Make a note of that, please. A database management system. Cashman 2004, Discovering Computers, stated that a database management system, software that is used to create a computerized database. Software used to create a computerized database. Database management system, abbreviated DBMS. A software that is used to create a computerized database. It allows you to add, change, and delete data in a database. It allows to add, change, and delete data in the database. You can sort and retrieve data from the database. So in the database, what's the word in database that means sort? I word. The database word that means sorting, I. Index. Remember those stuff? When you index, you sort the database. Retrieve. You can get data out of the database. What is one way in which you can retrieve data from a database? By using query. Very good, Aaron. So querying can be to pick out what you want out of the database. Something called filtering. You put in the what? C word. Put in a what? Criteria. You can put in multiple criteria. So you can select records based on the criteria. Database DBMS also allow you to create forms and reports from data stored in the database. The DBMS allows you to create forms and reports from the data stored in the database. I'm using the glossary. If you want, I can create it on Moodle. I can create glossaries. So if you want me to go in, I can create a glossary. Alright, so the glossary, I'll open the glossary for you.
So we have input it already.
I think I have to input for you. You can.
There's other things where they just all this.
Alright. The next, so we are now clear with what a database is from what a DBMS is. They are not the same. Now, spreadsheet and database looks the same. How comes? What do they have in common? So they store data in a tabular table format. But database is much more efficient than a spreadsheet because you can create data tables and store things in tables by themselves. And if you want the tables to work with each other, what do you create in database? Relationship based on the what? Keys, whether primary key or foreign key. And there's also secondary key, alternate key, candidate key, super key. Remember those from CXCIT? Good. So you'd realize that both of them have something in common. Now, I'm going to open for you on Moodle your handout on this. Please refresh your Moodle screen. You see a handout in week 2, CAPE IT Unit 2 Module 1 Objective 1 to 3 notes. You have to click on refresh or press F5 on the keyboard to refresh the screen. And go down to this week's work. Week 2. Go down. At the end of it, see there? A Word document, see there? See your notes now? So you see a handout for this week, CAPE IT Unit 2, Module 1 Objective 1 to 3 notes on Moodle. You have to press the page F5 or you press the redo icon and you're supposed to see it on screen. Now, having looked at your handout, you would see that there are different types of databases. There are 3 types of databases. And before I even say that, it might be very good for you to note on page 3 that there are a whole heap of databases. You have Microsoft Access, which is normally the more popular one because of Microsoft Office. You have DBase, you have FoxPro, you have Paradox, you have Approach, you have Oracle, Open Office Base. There is a lot of database management software around. Now, as you know, a database contains files, and with each containing records and fields. We look at now what is called a relational database. A relational database contains a table which are linked to each other. Each table contains record which contains field. A query can filter your records to show just the ones that meet your certain criteria or to arrange them in a particular order. So in a relational database, what you end up having in a relational database is if you have a table called patient, then in this table you would have like patient ID, patient F name, patient L name, date of birth, address, town. That's one table. over here, so we might have the child table, and instead of writing back the parent's name, we use the parent. Over here, so we have the visits table. So we'll have had the patient ID in this table again, no name. We might have the date of visit, the attending doctor, the medication, and the reason for visit. So as you realize that in this table, I have two keys. One is called patient ID, one is called visit ID. Which key is the primary key in the visits table? The visit ID is the primary key, because each time you go to the doctor, he records a particular number for you. You have a visit ID. So you go 10 times, you have 10 different visit ID. The patient ID again also, but this comes from this table right here. So in this table, in the patient table, this is the primary key of this table, but it's not the primary key of this table. What is patient ID in this table? FK. Foreign key. That's the foreign key. Alright? So the foreign key refers to the primary key in the next database table. It is not the primary key of the current table. How do you form the composite key for this table? How do you form the composite key? That's not supposed to happen, but we're checking out why. How do you form a composite key right here? What do you take? Pay attention, guys. Amari, this way. Pay attention. How do you form a composite key? If you don't, they just don't know. That's all I have to say. You take all the keys in the table. So you take the foreign key, patient ID, plus visit ID, and that forms the primary key. That forms the composite key, also called the super key. So it forms it. So all the keys in the table come together to give it the composite key. When you form a composite key for a table, it is now the what key in reality. It's now the primary key. You see you know it already? Those of you I taught? Did it to you guys, right? We're talking about the magnet, about keys and something in the class. May I drop ERD in the class and something there? I said to you, when you get to sixth form, Cape IT unit to it, come back all back to you. Remember those things in class, see people? It's okay, Amari, you'll catch up. You haven't done this in 2 years, that's kind of weak in your brain. Alright? So you can read up on the keys then. Read up on the keys. Alright? Now, as you know, there are other modules. A database, as you know, is a structured collection of data stored in a system. The structure is achieved by organizing the data according to a model. The models most commonly used is the relational model, where keys are used. You break tables up, which you're going to learn later on, something called normalization, where you break the tables up into smaller tables and store data in manageable tables based on their relation to each other, the records. And then the keys are used to store, to match, to link the tables. Because you can put all of this in this table and end up with a huge database table. But you would know in database, based on your SVA, that you break up tables into smaller portions. So the patient table will store things about the patient, and the visits table is talking about visits made to the clinic. Yes? Yes? Yes. Good. Now there are two other tables we have in database. Now the notes set here on the bottom of page 3, a computerized database has what is called a hierarchical model and also have what is called a network model. So the other two models are hierarchical model and network model. And the computer database relies upon a software to organize the data. So the software will organize the data. Now let me ask you a question. If you add a name of somebody to your cell phone, will it go to the end of the list? No. It automatically organizes itself amongst those you have already in your address book. Yes? So it says that a database software relies upon organizing the data stored inside of it. This software is known as a database management system. DBMS are categorized according to the database model that they support. The model tends to determine the query languages that are available to them and how they access the data. A great deal of internal engineering on DBMS is done. However, it is independent data model and is concerned with managing forces such as performance, concurrency, integrity, recovery of data, and hardware failure. Those things also affect the model that you choose. In these areas, there are large differences between the products of the different softwares. So Oracle database is totally different from Access database because it is a bigger database. Now, in the hierarchical model, data is organized into an inverted tree-like structure, implying multiple downward links in each node to describe the nesting, the sorting of field, to keep the records together in a particular order. So there's an upside down vertical triangle when you're drawing a model of it, a tree-like structure in a sense. A record that has a subsidiary record is called a parent, and the subsidiary record is called a child. Data elements in this model are well suited for one-to-many relationships. This model has the advantage that when data elements are inherited hierarchically. So if you add something to the parent database table, then the child table automatically get them, because you inherit properties from the parent database table. If you go into Google, you can go into, the net is down. You can go into Google, look in images. Make a note of that, please. Go into Google, look in images. Mary set up for class. Google images, and you will see images of the different models: hierarchical, relational, and the network model. So you can go on Google database models. Look for the images, please. And now, and again, might I remind you, your subject is not IT, it's advanced IT. So your papers, when you do your paper, it must say advanced IT. Now the network model. In the network model, records can participate in any number of named relations. Each relationship associates a record to one type called the owner with multiple records of another type called the member. These relationships, sometimes confusing, are called sets. For example, a student might be a member of one set whose owner is the course they are studying, and a member of another set whose owner is a college they belong to. You have to go into see the picture of the model. Let us see the models. At the same time, you need to look at that. The main difference between the network and the hierarchical model is that in a network model, the child can have a number of parents, whereas in a hierarchical model, a child only has one parent, as in one file above it. But in the network model, you can have several parents you get data from. So you belong to several different subject areas. Each subject teacher therefore will be a parent, while you are only a member of the class. So you have several teachers which are your parent, but each of you is a member. But all of it in the class becomes a set, which is a hierarchical, which is the network model. So therefore, the hierarchical model is a subset of the network model. You need to see the pictures on the Google. So if you get me some, you can let me add them. Network databases are traditionally implemented using a chain of pointers between related records, and these records have many nodes or numbers or disk addressing. So each CXC school location has a node. So Miss Miller, your CXC coordinate stays right here and upload all the records into CXC system directly in Barbados. So every school has a node, which is a network connection for the database, a password, and once she logs into the database from the school location or anywhere she is, she logs into Mona High School node. So anything she put in is Mona High School. So JC can't see Mona High School record because JC have their own login, their own code. So network models are very popular for large organizations where data is being input at different points. But like inside your schoolwork here, you don't use network model. You are using what kind of model? Which model do you use? What are the three models again? Network model, hierarchical model, and R, relational model. Which model do you use? Relational model. When you go into the company, when you go into banks, because all the banks have databases, each branch controls their own data, but all the branch network to each other in the same company. So you have NCB, all NCB ATM, all NCB banks all linked together in one network. Yes? But then all the NCB ATMs and all the Scotia ATM, all the RBTT ATM, all the ATM of banks except JMMB, they all link to each other in a network called what? Multi-link. You see the multi-link sign on those ATMs. So an ATM card from BNF can go into an NCB machine and get money out of an NCB machine. Because all that NCB machine does is route the transaction back to your branch and say that you took out money out of your account. And they update your branch at the local level. But they must store money on their side, which is the NCB side. So what would BNS do afterwards? At the end of every day, what will BNS do? Pay NCB the money. Because the NCB machine pay money to the Scotia account. Then at the end of the day, the central bank will tell BNS how much money they owe NCB and then send them a report of all the transactions that were run today. And then BNS will pay NCB. And then NCB pays BNS. Now please note that when a BNS customer is an NCB machine, they pay a fee for the transaction. Yes? So the bank take that money to recover the charges that they incur to carry out the transaction. So the bank get paid for it. They charge you a fee. But an NCB card with an NCB machine, you don't pay for the first couple of transactions. Like BNS also, you don't pay for the first couple of transactions. Now, you should know what are the advantages and the disadvantages, Mr. Williams. The advantages and disadvantages of all three models. To make a note of that, please create a table in your book, and you should know what are the advantages, disadvantages of each model in database and the appropriateness of use. So your table will have basically one column, which is a model, next column advantage, next column disadvantage, and next column appropriateness of use And if you want to be very brilliant, you could give me an example of a database. So if you give me relational model, then Microsoft Access must come here as the example of a relational model. But I believe the Oracle is a very powerful network database. Oracle. So if you go into very big companies, Oracle is a very old database. And when we describe these old systems in IT, we call them legacy systems. They are legacy, old systems. But new systems have to interact with old systems together. So please note them. So you have to know the disadvantages. They are in your handouts. Which is pages 3, 4, and 5. A database management system, as you know, is a complex set of software programs that controls the organization, storage, management, and retrieval of data in a database. When you're taking a note like this, something stand out, you kind of shade it out in your notes. You block it out. So when you're studying, that's the key point you need to learn, the definition. A DBMS, complex set of software program that controls the organization, storage, management, and retrieval of data in a database. DBMS are categorized according to their structures. It is pre-written programs that are used to store, update, retrieve a data. So they give you one more here. The 4 more common types. They give you one more right here. Object. So you have hierarchical, network, relational, and there's also object. See that? So you can look at those things. Data structures, database query language. Can anybody tell me what is the language used to write databases? Abbreviation. SQL, which stands for what? Structured query language. SQL. And you'll be writing SQL for your exam. You write SQL for your exam. So all databases are built on a programming language called structured query language. All databases. So you continue reading your notes. These notes were taken off the internet. Now, I won't start part 2 of your notes until Thursday when you have the main lecture. So you can read the other stuff in your notes, and we'll start part 2 of this presentation on Thursday.